Hello, welcome to this recorded class. This recorded class we are discussing the topic mathematical induction from the module 2 induction and recursion. Let's start the content. Here we are discussing some few examples about the mathematical induction. So mathematical induction means it is a mathematical techniques is used to prove a statement or formula or a theorem is true for every natural number. Okay, so mathematical induction means it is a mathematical technique used to prove a statement or formula or theorem is it true for every natural number or not. Okay, let us see the working rule here. Okay, I'm just giving the briefly the working rules, then we will go to the questions. See the working rule, basic step 1, what we are doing is the statement, whatever statement or formula or theorem, whatever given, the statement P of n, statement we are calling P of n. So this statement is true for initial values of n numbers are given, n equal to 1, 2, 3, 4 like. So what is the initial number? N equal to 1 or sometime n equal to 0. So n equal to 1, is it the statement is true or not? First we are checking. Okay, so first step, the statement P of n is true for initial values of n. Now when we are getting is this true, we will go to step 2. Then what we are doing in step 2, that is the inductive step. Assume that our result is true for n equal to k. Assume that our result, that means our statement P of n is true for n equal to k. We are assuming that one. After that, in step 3, we need to show that the result is true for n equal to k plus 1 also. Okay, so first initial step, the result is true for initial value of n, that means n equal to 1 mostly. Then assume that P of n is true for n equal to k, and we need to show that the result is true for n equal to k plus 1 also. So these three steps is true means what is the conclusion is that statement P of n is true for all natural number, for all values of n belongs to n. N means the set of all natural number. Okay, so this is the mathematical induction working rule. So let's see one example here. Example number 1. Prove that 2 plus 4 plus 6 plus 2n equal to n into n plus 1 for any natural number n by mathematical induction. Okay, so what is our statement here? We need to prove is that 2 plus 4 plus 6 plus even number, correct? Even numbers, when we are adding, we can use this rule, n into n plus 1. 2 plus 4 plus 6 plus up to 2n equal to n into n plus 1 for any natural number n by using mathematical induction. Okay, this is what our question here. So what is the statement actually here in this question? P of n. P of n means whatever the statement or theorem, okay, whatever given in the question. What is P of n here? 2 plus 4 plus 6 plus 2n equal, what will be the answer? N into n plus 1, correct? For any natural number, that means n number is, what is the n number here? Natural numbers. Natural numbers means the counting numbers, 1, 2, 3, 4, 5 like this, correct? So n equal to 1, 2, 3, 4 up to k plus 1 like that is going. So this is the n number here, it is given here, natural number, correct? So now we need to prove this by using mathematical induction. Okay, we need to check the statement is correct or not by using, or prove by using mathematical induction here. So let me start with the first step, step number 1. What I told in this step number 1, we need to check the result is true for n equal to 1 or not, or initial values of n. The statement P of n is true for the initial values of n. That is the first step we are doing. Now before going to the question, you can see this statement, you can see here left side and right side, correct? This is the right hand side of the expression, and here we have the left side also, left hand side of the expression we have. So step 1, what we are doing, that result we need to check the initial values of n. Initial value is what here? N equal to 1. So what we need to check in the first step is that P of 1, that means the statement at n equal to 1. Step 1 means the statement should be true for n equal to 1. We need to check because n equal to 1 is the initial value here. So we can check that one. What is p of 1? P of 1 is true or not. When n equal to 1, the left side and right side should be same. So what is the left hand side? First we can check left hand side, and what will be the right hand side? We can check. What is the left hand side here? You can take the nth term here. Nth term. What is the nth term here? 2n, correct? So left hand side 2n. What we need to substitute as n? 1. 2 multiply 1, correct? N equal to 1. So 2 multiply 1 means what will be the value? Equal to 2, correct? Now apply the right hand side. What is the right hand side? N multiply n plus 1, correct? What is the n value here? 1. Initial value 1 multiply 1 plus 1. So what answer we are getting? Equal to 2. That means the left hand side and right hand side is same, correct? Equal. Left and right hand side will be equal. That means what we can say? P of 1 is true. That means the statement is true for n equal to 1. P of 1 is true. That means the statement is true for n equal to 1. This is the first step we are doing. Okay, the statement is true for n equal to 1. That is first we are checking. So here it is true. P of 1 is true here. Now once you finish step number 1, we will go to step number 2. What is step number 2 here? Step number 2 means assume that. We are assuming. Assume that the result is true for p n equal to k. See, assume that p of n is true for n equal to k. That means assume that p of k is true. P of k means p of n is true for n equal to k. Just apply n equal to k. That is p of k. P of n is our statement, correct? Put n equal to k. P of k. So assume that p of k is true. What is the meaning p of k actually? You can apply here this p of n statement. 2 plus 4 plus etc. plus 2n. Instead of n, what you are applying? K, correct? N equal to k. That means step 2 we are doing put n equal to k. That means 2 plus 4 plus 6 plus 2k equals n into n plus 1. Instead of n, what we need to write? K. So k multiply k plus 1, correct? This is we are assuming this is true. 2 plus 4 plus up to 2k equal to k plus 1. K multiply k plus 1. We are assuming that one. We are just applying this is substituting this as equation 1. Okay. Just to give that equation as equation number 1. Statement number 1. Now, what is the step number 3 we need to do? We will go to now step number 3. This is the most important step here. Step number 3. That means we need to show that. Okay, that is the step number 3. What is step number 3? We need to show the result is true for n equal to k plus 1. That means what is we need to do? We need to show that. Okay, I'm just writing here. We need to show that p of k plus 1, that is p of n at n equal to k plus 1. P of k plus 1 is also true. We have to prove this one, correct? We need to show that p of k plus 1 is true. Now, what is actually p of k plus 1? P of k plus 1 means, what is p of k plus 1? Just apply here in the p of n statement. 2 plus 4 plus 6 plus 2 plus 4 plus 6 plus 2n. 2 multiply, instead of n, what you need to write? K plus 1, correct? 2 multiply k plus 1 equals n multiply n plus 1. N means what we need to apply? K plus 1, correct? Multiply n plus 1. N plus 1 means the n into n plus 1. This is, instead of this n, we are writing k plus 1. So here what happened? This n become k plus 1 plus 1. N plus 1, correct? N means k plus 1. So what we will get actually? K plus 1 multiply k plus 1 plus 1 means k plus 2, correct? So this is what we are writing here. So p of k plus 1 equals k plus 1 multiply k plus 2. This is what we need to prove here. Okay. In step 3, we need to prove this one. 2 plus 4 plus 6 plus 2k plus 1 equals k plus 1 multiply k plus 2. See, this is the left hand side here. LHS, and this is the right hand side, correct? So what we need to prove here, left hand side equal to right hand side. We need to check is it correct or not. If you are getting left hand side equal to right hand side, P of k plus 1 is true, correct? So just start from the left hand side. What is the left hand side here? Equals 2 plus 4 plus 6 plus continuing plus 2 multiply k plus 1. 2 multiply k plus 1. This is the left hand side, correct? Now what we need to do is, see, this is the last term here, k plus 1, okay, 2 multiply k plus 1. Just write the term before this one. What is the term before that one? 2k, correct? 2 multiply k, that is the term just before that term, okay? That is, you can see the step number 2. This will be the term before that one, 2k, okay? You can just clear from here. This will be the term just before 2k plus 1. Now what we are doing is, see, already we know 2 plus 4 plus 6 plus up to 2k. What is the value we are given in step number 2? 2 plus 4 plus 6 plus up to 2k means what is the value is given? K multiply k plus 1, correct? So I am writing, instead of that one, I can write k multiply k plus 1, correct? 2 plus 4 plus 6 plus up to 2k. I can write k multiply k plus 1 plus this term we are writing same. What is that one? 2 multiply k plus 1, correct? Now just to simplify, equals. From these two terms, what term we can take it common? You can think. See, k plus 1 here is there. Here also k plus 1 is there. I am just taking that term into outside. So k plus 1 multiply, what will be balance? You can check. What is balance? Here one k will be balance. So k, here plus 2 is balance, correct? So k plus 2. So what we got answer? Left hand side we are started. We got the answer k plus 1 multiply k plus 2. Is it same as the right hand side here? You can see here. The right hand side also k plus 1 multiply k plus 2. That means it is same as the right hand side. That means left hand side equal to the right hand side, correct? That means P of k plus 1, 2 plus 4 plus 6 plus 2k plus 1 equal to k multiply k plus 2. What is the meaning of this one? Left and right same means P of k plus 1, that statement is also true, correct? Pk plus 1 is true. So what happened actually? First we proved P of 1 is true. Then we assumed P of k is true. Now step 3, what we proved? P of k plus 1 is also true. So we can conclude now. Now we can write the conclusion. So what will be the conclusion? By mathematical induction. Therefore I am writing the conclusion here. What is the conclusion? By mathematical induction. By mathematical induction, P of n is true. P of n is true for all natural numbers, correct? For all natural numbers. This is what the mathematical induction we are doing. First we are checking P of 1 is true. Then assume that P of k is true. We have to prove that P of k plus 1 also true. Then we can conclude by mathematical induction that statement is true for all natural number. I hope you understood this question. Let me go to the second one, example. Example number 2. Prove that 3 power n minus 1 is a multiple of 2 for n equal to 1, 2, 3, etc. by mathematical induction. Okay. So you can see this question. What is we need to prove by mathematical induction? What is P of n? What is our statement? What is our statement here? 3 power n minus 1 is a multiple of 2. This is what our statement, correct? P of n means 3 power n minus 1 is a multiple of 2. N equal to what are the number? 1, 2, 3, like that is going, correct? That means if you put n equal to 1, 3 power 1 minus 2, check this number, it is 2. It is a multiple of 2, correct? Multiple of 2 means what are the number? 2, 4, 6, correct? 8, 10. These numbers are multiple of 2, correct? So 3 power, if you are putting n equal to 1, it is a multiple of 2. Same like if you are n equal to 2, 3 power 2 minus 1, what will be that number? 3 power 2 is 9. 9 minus 1 is 8. 8 is also a multiple of 2. So if you are putting any number n equal to 1, 2, 3, etc., 3 power n minus 1 is always a multiple of the number 2. That is what our question here. Now when we are going to the question, see, we have this statement, we have two parts, 3 power n minus 1. Just assume this is the left hand side of the statement, and is a multiple of 2 is the right hand side. Just assume like that one, right hand side is means is equal to, is a multiple of 2. So we have one left hand side of the expression and we have one right hand side of the expression, correct? That statement. Now we are starting with the proof now. What is the first step we need to do? Step number 1. Okay, basic step. The result is true for the initial value of n. What is the initial value of n here? N equal to 1. You can see here n equal to 1 is the initial value. So just to check p of 1 is true or not, okay, we need to prove p of 1 is true. So what we do, just left hand side of the expression. What is the left hand side of our statement? 3 power n minus 1. What number n equal to? N equal to 1, p of 1, correct? P of 1, just substitute n equal to 1. So what you will get? 3 power 1 minus 1. What is 3 power 1 minus 1? 3 power 1 is 3, 3 minus 1 is 2, correct? Now what is the right hand side? Is a multiple of 2, is it correct? Yes, 2. 2 is a multiple of 2, correct? So right hand side also correct. Is a multiple of 2, correct? That means what is the meaning? P of 1 is true. P of 1 is true here, because we are getting here, see, is a multiple of 2 means it is the right hand side, correct? So when we are applying n equal to 1, we will get a number 2. That number is a multiple of 2. That is correct. We are getting correct right hand side. So right hand side and left hand side both are correct. It is statement is correct. 3 power n minus 1 is a multiple of 2. So p of 1 is true. So the first step is over. Now we will go to the second step. Step number 2. Step number 2. What is step number 2? Assume that p of k is true. P of k is true means what is the meaning? P of n is true for n equal to k, correct? That means p of k is true. What is p of k actually? P of k is true means what is the meaning? P of k, 3 power, instead of n just apply k, 3 power k minus 1 is a multiple of 2, correct? In p of n, this statement, p of n statement, instead of n just apply k, 3 power k minus 1 is a multiple of 2. This is the statement 1 for assume that this is statement 1, 3 power k minus 1 is a multiple of 2. Now what we need to do in step 3? Step number 3, we need to show that, correct? We need to prove, what we need to prove? P of k plus 1 is also true. P of k plus 1 is true. We need to prove that, correct? What is P of k plus 1 actually? 3 power, instead of n just substitute k plus 1. So 3 power k plus 1 minus 1 is a multiple of 2, correct? Is a multiple of 2. We need to prove this one. 3 power k plus 1 minus 1 is a multiple of 2. Just assume, see, 3 power k minus 1 till the left hand side of the statement, and is a multiple of 2 means it is the right hand side of the statement. Is means is equal to, is, you can assume like that. Okay, now we need to prove this one. Left hand side you start, you will get right hand side or not. Okay, so I am just starting from the left hand side. Left hand side of that statement means 3 power k plus 1 minus 1, correct? 3 power k plus 1 minus 1. Now how to write 3 power k plus 1? Actually we can split into 2. 3 power k plus 1 means 3 power k multiply 3 power 1 minus 1. We can split, we can separate into two terms. You know that one, 3 power k multiply 3 power 1 minus 1, correct? Now equal to, just think our assumption. What is our assumption here? 3 power k plus k minus 1 is a multiple of 2. This is what our assumption. So here 3 power k, this 3 number, how to write that 3 number? 2 plus 1, we can write 2 plus 1, correct? Why we are writing that one? You can see minus 1. Instead of 3, I am writing 2 plus 1 because 2 plus 1 is same as 3, correct? Now just expand this one. See, multiply here. So you will get equals 3 power k multiply 2 means 2 multiply 3 power k plus 3 power k minus multiply 1 means 3 power k, then minus 1. Okay, 2 multiply 3 power k, 1 multiply 3 power k, and minus 1. Now think about that one. Okay, can we assume the steps, apply step 2 here? See, 3 power k minus 1. What is telling in the step 2? 3 power k minus 1 is a multiple of 2, correct? 3 power k minus 1 is a multiple of 2 from step number 2. See here 3 power k minus 1. So what is, this is a multiple of 2, correct? This is a multiple of 2. Why? Because from step 2 already we are written 3 power k minus 1 is a multiple of 2. Now what about the first one? 2 multiply 3 power k, is it a multiple of 2? Yes, because 2 multiply coming means it is also a multiple, it is also a multiple of 2 because 2 multiply means multiple of 2. That means all, first term is a multiple of 2, second term also is a multiple of 2, means all together is also is a multiple of 2. Yes, is a multiple of 2 because first term is a multiple of 2, second term is also a multiple of 2. So all together is a multiple of 2. That is the right hand side. See, is a multiple of 2. That is the right hand side here. So same as the right hand side, correct? We can say same as the left hand side of the statement, same as the right hand side. That means 3 power k plus 1 minus 1 is a multiple of 2. That is the meaning. That means what we can say this one, p of k plus 1 is also true. P of k plus 1 is true. So P of 1 is true, P of k is assumed, P of k plus 1 is true. So what we can conclude? We can conclude that P of n is true, correct? P of n is true for all natural numbers. P of n is true for all natural numbers. This is what the question we are doing. So I hope you understood why we are splitting here 2 plus 1, because we need these two terms separately. That's why we are splitting here. We need 3 power k minus 1, then we can use this step 2. For that we are dividing 2 plus 1. Okay, so keep in our mind that step. Okay, now let me go to the question number 5 here. Some of the question only I am solving this recorded class. Remaining questions it will come in the next recorded class. Okay, now let me go to this question number 5. Prove that 11 power n minus 4 power n is divisible by 7 for all n greater than or equal to 1 by mathematical induction. So you can see what is the statement here, P of n. What is P of n here? 11 power n minus 4 power n is divisible by 7. 11 power n minus 4 power n is divisible by 7. This is the statement here. Now what is our n number here? N is given, n greater than or equal to 1. N greater than or equal to 1 means what are the number? 1, 2, 3, 4, 5. That means the natural number, correct? More than 1 and more than 1. 1, 2, 3, 4 like continuing. That is the natural number. Now before coming to the step number 1, just think about what is the left hand side of the statement here. This is the left hand side of the statement and this is the right hand side of the statement. Just assume like that one. Okay, 11 power n minus 4 power n is divisible by 7. That means when you are substituting n equal to 1, 2, 3, 4, whatever 11 power n minus 4 power n, always it will be divisible by 7. For example, see, when you are substituting n equal to 1, what is you are getting? 11 power 1 minus 4 power 1. 11 minus 4 means it is equal to 7. 7 is divisible by 7, correct? So because it is divided by 7, you will get an integer number 1. That is the meaning divisible by 7. Like that, if you put n equal to 2, you will get a number divisible by 7. Put n equal to 3, you will get a number divisible by 7. That is the statement here. So we need to prove that one, it is correct or not. 11 power n minus 4 power n is divisible by 7. Okay, so let me start the proof here. So first step, step number 1, initial step, we need to check p of 1. The statement is true for n equal to 1. Just apply in the left hand side of the statement. What is the left hand side? 11 power n minus 4 power n. What is 11 power n means 1, initial number, minus 4 power 1. What is 11 minus 4? 7. Is it divisible by 7? Yes, because when we are dividing by 7, we will get an integer number, 7 by 7. We can divide. It is possible, correct? So it is same as the right hand side, correct? Is divisible by 7. This is actually the right hand side of the statement. So whatever the number you are getting here is divisible by 7, correct? So what is the meaning that one? It is true. So p of 1 is true. P of 1 is true here. So the first step is over now. Now we will go to the second step. Step number 2 here. What is step number 2 we need to do? Assume that p of k is true. Assume that p of k is true. What is p of k actually? P of n is here. What is p of k? Put n equal to k here. Replace n by k. 11 power instead of n, write k. Minus 4 power instead of n, write k. Is divisible by 7. Is divisible by 7. Correct? So this is p of k. So assume that this is true. 11 power k minus 4 power k is divisible by 7. We are assuming that one in step 2. We can give this is number 1, expression number 1 in step 2. Now we will go to the step number 3 now. What step 3 we need to do? Based on that assumption, we need to prove that, or we need to show that, we need to prove that p of k plus 1 is also true. P of k plus 1 is true. Actually, what is p of k plus 1? Just apply here. P of n statement, put n equal to k plus 1. So how to write that statement? 11 power k plus 1 minus 4 power k plus 1. This should be divisible by, is divisible by 7. This is what we need to prove here. 11 power k plus 1 minus 4 power k plus 1 is divisible by 7. See, this statement, we can assume this is the left hand side, and we can take this is the right hand side of the statement. Okay, hope it is clear to you. Now we need to prove this one. So what you do, just start from the left hand side. Okay, what is the left hand side? 11 power k plus 1 minus 4 power k plus 1. Okay, simplify. Okay, simplify. You need to get the answer. That one is divisible by 7. That means the right hand side. Then p of k plus 1 is true. So how to write 11 power k plus 1 minus 4 power k plus 1? We can write 11 power k multiply 11 power 1. Correct? Because we can split that one. 11 power k, 11 power 1. Minus same 4 power k plus 1 also we can split into 2. 4 power k multiply 4 power 1 here. Hope you clear this one. Correct? Now, like last question, we need to change this 11 number. How to change that 11 number? Just think about what is the number here, 4. So how to write 11 in terms of 4 also? 11 power k. 11 means how to write that one? 4 plus 7, correct? 4 plus 7, because 4 plus 7 is 11. Why we are taken 4? Because this last number we can see 4 is there, we can take common if you are doing like that. So 4 plus 7, then minus 4 power k multiply 4. Hope you understood this step. Now here expand the bracket. Okay, expand this, expand here, multiply. So what we will get here equals 4 multiply 11 power k, correct, plus 7 multiply 11 power k minus 4 power k multiply 4. We can write 4 multiply 4 power k, correct? Just divided into 2. Now you can see the first and last term. What term we can take it common? Outside take it. From here and from here, what term we can take common? 4 is common, correct? So take it outside that one. So how to write that step? Equals, I am taking 4 outside, so 4 multiply, what will be the remaining here? 11 power k in the first term minus 4 power k will be the second term balance, correct? 4 already we are taken outside, so minus 4 power k balance plus 7 multiply 11 power k, that is same, 7 multiply 11 power k. Hope you understood this step. Now think about this one, the first one and the second one separately. Think about this one, 11 power k minus 4 power k. It is already we are assumed in step 2. 11 power k minus 4 power k is divisible by 7, correct? So here see 11 power k minus 4 power k is there. So this term is divisible by 7. Now what about this term? 7 multiply 11 power k. 7 multiply 7 number is there, so we can divide by 7 easily, correct? So this is also divisible by 7. I hope you understood. First one, this one, the first part is from step 2. Okay, from step 2 already we assumed that one. This first part, 4 multiply 11 power k minus 4 power k, that is from first part, it is divisible by 7 from step 2. Second one, 7 multiply 11 power k means this number we can divide by 7, because 7 is there, we can cancel, we will get an integer number. That's why it is divisible by 7 here. So totally what we can write, first term is divisible by 7, second term also divisible by 7. So totally what we can say is divisible by 7. That is the RHS, right hand side, correct? Equal to the right hand side. That means 11 power k plus 1 minus 4 power k plus 1 is divisible by 7. Hope you understood. That means, what is the meaning? That means p of k plus 1 is also true, correct? So first we proved p of 1 is true, then we assumed p of k is true, now we proved p of k plus 1 also true. That means, what is the conclusion? We can conclude by conclusion p of n is true. P of n is true for all natural numbers. All natural numbers, correct? So that means our statement is true for all natural numbers by mathematical induction. Hope you understood these three questions related to mathematical induction. Okay, thank you for watching. Please subscribe my channel for getting more recorded classes. Thank you very much.